Okay, this presentation is over basic Unix commands. So I want to show you a handful of commands that you might use on a regular basis on a Unix machine. And what I'll do is I'll go through my slides and talk about several of these commands, and then I will go back and actually issue those commands or examples of those commands within a terminal or shell window on a Unix machine so that you can see what they are actually doing. So the first command that I think you'll use quite a bit is the ls command. And ls is an abbreviation for list, and it lists the contents of a directory or a portion of the contents of the directory, as we'll see in a moment. One thing that I want to address, a lot of times people complain about Unix commands being cryptic and maybe not making sense, but the designers of Unix back in the late 60s were all about efficiency. So the commands that you issue the most often are going to be the shortest so that you can type them quicker. The other thing is a lot of Unix commands don't give you output. I used to have students issue the password command to change their password, and they go, "It didn't change my password." And I'd ask them why they thought that, and they said, "Well, it just gave me a prompt back and didn't give me any output saying that it actually changed my password." And I tell them no output is a good thing. You ask the Unix machine to do something and it did it for you. If you get output, it's going to be a warning or an error saying that you did something wrong. So like I said, no output is a good thing. So back to the ls command. If we simply say ls by itself, it's going to list the contents of the current directory, which is sometimes called the working directory. That is where you actually are residing within the Unix file system at that point in time. If you issue the ls command by itself, it's just going to give you a list of file names. If you issue it with the -l option, which stands for long, you're going to get a long listing of the contents of the current directory. So each line will contain information about one file. It'll have the permissions for that file, who owns the file, what group owns the file, the size of the file, the date time the file was last modified, and the file name of that file. So it gives you a lot more information. And we'll discuss that when I'm actually doing kind of the hands-on portion of this. Unix has a concept of hidden files. Hidden files are simply files whose name starts with a period. Not on all Unix systems, but on original Unix systems and most Unix systems, if you do an ls or an ls-a, it's going to show you all the files with the exception of hidden files. A lot of times these hidden files are configuration files, you know, that you need to be there for something to function correctly, but you don't necessarily need to be reminded that they're there or see them when you're doing your day-to-day work. If you would like to see those hidden files, you add the -a option. So ls-al will show you all files, including hidden files, in the current directory, and it will do a long listing for each of those files. This is not a Unix sysadmin class, so I probably won't spend a lot of time on wildcards, but you have these things called wildcards that you can use at the command line, and one of the most common wildcards is the question mark. Is the asterisk. The asterisk represents 0 or more characters. Since I slipped up and mentioned the question mark, a question mark is a wildcard that represents one and only one character in that position. So the example I've done here is ls star.py. This will show you all the files in the current directory which end in .py. which are presumably going to be Python programs. Sometimes we need to delete files. The way we do that is with the remove command, which is abbreviated RM. The syntax of that is remove, and you give one or more file names, and any file names that are listed will be deleted from the system. We have a Unix file system, which we will see an example of a little later in this presentation, but we have ways that we can move around the file system, and if you want to know where you're located within that file system, there is a command pwd, which stands for print working directory. So it will give you the path name to the directory that you currently reside in on the Unix machine. Sometimes you want to get organized. When I go through the example, you'll see that I created a directory called CIT144, where I'm going to put examples and solutions to programs. So I had to use the mkdir, mkdir command, and what I did is I logged in, I was in my home directory, and I said mkdir space capital CIT144, and it created a directory with that name. Now, one thing to point out, since I specified all capital CIT144, is Unix machines are case sensitive. So you can have a file called lowercase abc, and a file that's all capital ABC, and a file that's capital A, lowercase b, lowercase c, and those are actually three different files with three different names on a Unix machine. So file names are case sensitive. To make the directory, like I said, you say mkdir and the name of the directory that you want to make. Now, I alluded to the fact that you can move around the Unix file system, and the command that you usually use to do that is the cd command. And the syntax of the cd command is cd space path name, and path name is where you want to change to on the file system. If you issue the cd command with no arguments, just simply cd return, it's going to take you back to your home directory. And your home directory is where you start out when you first log into a Unix machine. Now, one thing to note is that when I say path name, Unix has the concept of absolute paths or relative paths. And the best way to discuss this is to show you a Unix hierarchy. So what I have here is a very small portion of a Unix file system. The file system I did this on, or modeled this after, had something like 11 million files on it. So there are lots and lots and lots of files on there, and they may be in user home directories or they may be system files. But this is a hierarchical file system, which basically means it looks like an upside down tree. Now, when I draw a picture of the file system, rectangles are directories and ovals are files. And you'll notice at the top we have a directory that is represented by the slash. That is referred to as the root directory, or if somebody said slash, they would know what you were talking about. Under that root directory, the topmost directory on a Unix machine, we have a whole bunch of directories, and I've just listed a few here. USR, pronounced user, is for user files. SBIN is for system binaries, so programs that normally a system administrator would use. Over to the right we have the bin directory, which is where commands like ls and less that I've shown here are going to exist. There's going to be a whole bunch of commands in bin. Under user, We have a bin directory, a local directory, a lib directory. Under user bin, that's going to be user commands. So one of the editors you might use on a Unix machine and that we're going to talk about in a later presentation is VI. Under /home, that's where your home directory is going to be. My user ID is wbeach0001. Within my directory, I might have a test.py Python script that I was testing something. And then there's that CIT 144 directory I talked about. Within that CIT 144, I may have homework6.py, and then I might have, the first programming assignment, program 1 or PGM1 .py. Now then, what kind of started this was absolute and relative path names. So absolute path names start with a slash. And basically what you're doing is you're starting at the very top of this tree and giving a complete path. So for example, that homework6.py program, if I wanted to give an absolute path to that, I would say /home /wbeach000 / all capital CIT 144 /hw6.py. So I started at the tree and walked us all the way down. Now then, for an example of a relative path name, let's say I logged into this machine, did not issue the cd command, so I'm currently residing in /home /wbeach0001. If I wanted to reference homework 6, I could say ./CIT 144 /homework6.py. The dot means the directory I'm currently in. If I wanted to edit this test.py program, I would just say vi space test.py. So there's a couple of examples of relative path names. So another thing that you might do is, let's say you cd'd into /bin and you didn't find the executable you're looking for, and you said, oh, that's probably in sbin. You can say cd space .. /sbin. So ... means the directory above me. So from bin, go to the directory above me, and then go down into sbin. So that is a way to kind of move sideways, if you will, within the file structure or the file system. Going back to some useful Unix commands, the move command allows you to move a file or files and or directories to a new location. So let's say I started creating my programs in my home directory, and then I wanted to get organized, so I created a CIT 144 directory. I would then need to move all the programs that I'd already written that resided in my home directory down into that CIT 144 directory. So where they were before, it actually moves them, so they no longer exist in my home directory, but now they exist down in my CIT 144 directory, for example. The syntax is move and then one or more sources, and then the very last argument is the destination. So if your source is a single file, your destination is going to be a file with a different name. So that's basically how you rename a file, is you move it from the old name to the new name. Now, in the fictitious situation I was telling you before, let's say I had created 3 programs before I decided to get organized. So I might say move space program1.py space program2.py space program3.py, and then the last argument, my destination, would be the all capital CIT 144. So in that case, it would move those 3 programs down into my directory. Another command that you will use often, and definitely when you're submitting solutions to your programming assignment is the command to display or type out the contents of a file. Now, you might expect it to be print, you might expect it to be type, but the actual command is cat. So that will list the contents of a listed file or files. Now, cat is an abbreviation for concatenate, which, that might not still make sense to you as to why this isn't type or something a little more obvious. But when I go through and show you the commands, we'll see if it makes a little more sense. But basically, the concatenation of a single file is the file itself. So if you say cat space program1.py, it's going to display all the contents of program1.py. If you need to make a copy of a file, there may be situations where you write, for example, a program 3, and then I say, okay, you're going to modify your program 3 so that it has error checking, or modify it so it does something additional. And you've already created and presumably submitted program 3, and that's your starting point. So what you might do is you might say copy program3.py to program4.py, and then you would go in and modify program4.py to add the error checking, the new functionality, whatever we were talking about. The syntax of the copy command is, as I just gave you in the example, copy a existing file to some new file name. And once that command issues, at that point in the time, those two files will be identical. Just like the move command, you can copy one or more files into a directory. So if you copied program 1, program 2, and program 3 into the CIT144 directory, you would still have all three programs in your home directory, and now you would have identical copies of them in your CIT144 directory. Okay, what I would like to do now is to log into a Unix machine, in particular the Unix machine we'll be using for this class, and go through and do a demo of some of the commands that we just talked about. Here's a terminal window running on my Mac that's logged into the Grace server, the server we will be using for some or possibly all of our programming assignments. You will see I have the prompt, which you can change, but by default is my user ID at the short name of the server that we're logged into, which is Grace. After the colon is the current directory. And we talked about relative and absolute path names. The tilde, the little squiggly line that's shown there, is a special relative path name that refers to my home directory. And then the dollar sign is just the prompt. So it's basically sitting there asking me what I want to do. Now I'm going to issue some of the commands that we talked about previously in this lecture. And the first one is pwd. So that is print working directory. And right now, when I log in, I start out in my home directory, which in my case is /home/wbeach0001. If I do an ls command, it shows me the name of all the files that are in my account. Again, Unix has a concept of hidden files. So if I truly want to see all my files, including hidden files, I would need to add the -a option to the ls command. So here I'm doing an ls-a, and you will notice that I now have file names that begin with a period. Dot is a special name that refers to the current directory. Dot dot refers to the directory above me. You'll see that I have 3 files that start with .bash. These are configuration files or history files related to the bash shell. There are other dot files there. Again, these are typically configuration type files. If I want more information about the files, I add the -L option. So if I do an ls-l, I get a long listing. And the first 10 characters are the file type and the permissions. We'll come back and talk about that in detail here in a moment. This column is the owner of the file. The owner of the file typically starts out as the person that created, and in the case of users, will often always be that user will be the owner. But you can actually change the ownership of a file to somebody else. The next field, which unfortunately has a space in it here, but is domain users. That is the group that owns the file. This next column is the size of the file. The next 3 columns are the date, time the file was last modified or last changed. And then finally the last column is the name of the file or directory. So that's what you get when you get a long listing. Again, I don't want to dive as deep into Unixy type things as I would in my Unix sysadmin class, but let's go back and talk about these first 10 characters. The first character will tell what type of file it is. So if it's a dash, it's a regular file. If it's a D, it's a directory. And there are some other characters like L for link, S for socket, P for pipe, etc. So those are different types of files, system objects that you can have on a Unix machine. The next 9 characters are 3 groups of 3 bits. Those 3 bits are referred to as read, write, and execute. The first 3 are what permissions the owner has. The next 3 are what permissions people in the same group have. And then the last 3 are referred to as other. So if you're not the owner, not in the same group, those permissions apply to everyone else. If there's an R present, that means you have read permissions. If there's a W present, it means you have write permissions. And if there is an X and it's a regular file, that means you have permission to execute or run that file. If it is a directory and that you have that X permission means you're allowed to change into or pass through the directory. So another command we talked about was the cd command. So let's say I cd to /user local, and it's just going to simply give me the prompt back, but notice that my prompt told me where I was. If I do an ls, I'll see that I have some directories there. If I cd down into bin, my prompt is going to tell me I'm in user local bin, but if I did not have that in my prompt, then I could do a pwd and it would say you're in /user/local/bin. Now then, on a couple occasions we talked about this special file name or relative path component ... which refers to the directory above me. So if I'm in user local bin and I cd up 1 level down into source, now I'm in /user/local/source. And again, if I didn't have that in my prompt, I could do a pwd to see where I was. If I issue the cd command without any arguments, that's going to change me back to my home directory, which it's going to use the shortest version available, which is tilde. But if I do a pwd, it's going to give me the full path name, which is /home/wbeach0001. Now, if I cd down into my CIT 144 directory and I do an ls, you'll see that the only thing I have there is the example.py program that I used in a previous video. If I wanted to see the contents of that file, we talked about the cat command, and I can simply say cat example.py or whatever file I wanted to view, and if I hit return, it's going to go through and show me that little example program that we had used previously. So those are some sample Unix commands that you might be using on a regular basis when you're creating your programs, running your programs.